Good morning. My name is Elza Fonseca. I'm from Portugal, Polytechnic Institute of Porto. And the title of my communication is the following: Solution Methods for Temperature Evolution on Steel Members Submitted to Fire. The main topics are the following. First of all, I'll speak about steel and wood material, why, and also about the hybrid wood-steel material in combination. Then present some objectives of this work, the thermal properties of the materials, present the geometries and local notations to obtain the results, present the numerical models and the fire action, the numerical simulation and the results. Finally, some discussion about the work and conclusions. The main objective of this work is to verify the solution methods for temperature evolution on steel members submitted to fire using hood helmets to delay the temperature evolution. This type of work is based on some regulation, namely the Eurocodes, Eurocode number 1 for fire design, Eurocode number 5 for timber material, and Eurocode number 3 for design of steel members. About the topic, why steel material? Steel is a traditional material construction widely used due to extremely strong, durable, high structural strength, but steel material loses strength when it is heated sufficiently. Steel is a good conductor of heat, which reduces the fire resistance of the members. Steel has also a higher labor cost. Here you can see some different applications in buildings using steel material, bridge, beams, different applications in construction. About the wood material. Why wood material? Wood is a natural and the earliest construction material used by the humanity. Is easy to use, durable, great architecture features, high strength, low height, widely available and low cost. But wood is a combustible material, but the combustion is slower and regular. When wood is exposed to high temperature, like a fire for example, a shear layer is formed insulating the section core, as you can see in the first picture. According to the regulation, Eurocode number 5 for timber material, the temperature between the shear layer and the core section is around 300 degrees. Here you can see in this picture the shear layer formation and the intact wood inside the member. Wood is typically used in different applications in construction, like building frames, bridge, flowers, roofs, beams, different construction buildings. Why hybrid wood-steel material? The combination between wood and steel leads to economic and ecological benefits, optimization, fire and structural resistance increase, and an efficient assembly between the elements. In this graphic, you can see the comparison between wood and steel according to their strength. As you can see, if increase the fire exposure in the cross member, the strength of wood is always constant, but the strength of steel decreases with increase the time at fire exposure. The performance of wood members under fire conditions is higher compared to unprotected non-combustible material construction, and steel melts and collapses while the shared wood remains in place. Some applications according the combination between wood and steel elements, new buildings projects, for example, in bridge, slabs, roofs, different examples. The main objectives of this work are to produce the temperature time history for different design solutions submitted to different fire conditions and to verify the best constructive solution which increase the fire resistance. The methodologies used are the following. All models were developed by the fine-tuning method. The numerical thermal simulation used a transient analysis with ANSYS program. In this program, we use a plane-defined element with 8 nodes and 1 degree of freedom by node representative of the temperature. For the transient thermal analysis, standard temperature time curve was used according to the regulation, the Eurocode number 1. As you can see in this graphic, representing the temperature evolution according to the time fire exposure. Now the topic for thermal properties. Wood and steel thermal properties used in the numerical model are temperature dependent according to the regulation, the Eurocode number 5 for timber material and Eurocode number 3 for steel elements. The typical properties used in our model are density, specific heat, and thermal conductivity as represented in these graphics. The first graphic in the left side representing all thermal properties for steel material, and the right side you can see the behavior for the wood elements. In this slide, we represent the geometries and the nodal locations used to obtain the numerical results. 3 different geometries submitted to fire were analyzed, and 4 nodal positions were considered to obtain the temperature during 1 hour of fire exposure. As you can see, the first line of this table represented the geometry number 1 for 1 side of fire exposure or 3 sides of fire exposure, and the same for the geometry number 2 and the geometry number 3. Now about models and fire action. We studied 24 different models due to the combination between the materials and the combination between the different fire actions, and more 4 models with the air internal divide cavities of the elements. In this table, we can see all different geometries. In the first line, the geometry number 1, considering the combination between materials, only wood, only steel, wood and steel, or steel and wood, and also the effect of the fire action in 1 side or 3 sides. And the same for geometry number 2 and for geometry number 3. Also, the geometry number 3 were considered when the internal cavity have the effect of the air internal divide cavity. About numerical simulation, all temperatures in our models were obtained during 1 hour of fire action. The boundary conditions are convection and radiation according to the temperature evolution in fire. For fire action external to the elements, we consider the external curve due to regulation according to Eurocode number 1. And in the model number 3, the geometry number 3, when we needed to introduce the effect of the air internal divide cavity, as you can see in this picture, the thermal properties of the air are considered according to the specific heat density and the thermal conductivity values and the temperature dependent evolution, as you can see in this graphic. Now about numerical results. In this slide, you have the numerical results for the geometry number 1, when we have one side exposure to fire or three sides exposure to fire. The first line of results represent the elements in wood material. The second, when we have only steel material. The third line of the results represent the cross-section when we have wood material in the top of the cross-section and steel in front of fire. And the last line of results represent the cross-section in steel and wood material in front of fire. As a general conclusions about these results, the elements that have wood in front of fire exposure, as the last line, for example, protects the cross-section, as you can see in blue color of this image. Steel in front of fire, for example, the third line of the results, quicks hit all component, as you can see in this image. In this slide, you can see the numerical results, but now using the geometry number 2 for the same situations in fire action, one side and three sides of fire exposure. The line represents always the same combination between materials. The first line wood material only, the second only in steel, the third wood and steel, and the last line represents steel and wood material. Now the conclusions are different from the previous. Wood elements in front of fire are very thin due to geometry, and quickly lose their resistance due to shear layer. And for the model number 2, the better performance is in the model in steel material, for example. Is different from the previous. The numerical results for the geometry number 3 in the same situation due to fire action are represented in this slide for the same combination between the wood and steel material. Also, you can compare the solution when we have a void cavity without air and the void cavity between the cross-section but introduce the thermal properties of the air. General conclusions: when wood is externally applied to the steel, plays an important role as insulation, reduce the temperature inside the steel. In case where both outside and inside of the model are made of steel, the temperature in the inner profile is higher than the previous solution. When we use the thermal properties of the air internal the cavity, you can see also the evolution due to heat conduction through whole cross-section. And finally, some general conclusions. According to our numerical results, wood elements present lower temperature than steel. The fire exposure at three sides is the worst fire situation in general, and the hybrid models can perform well under fire conditions. The model here gives similar results to the internal insulated elements, but shows the heat conduction inside the element. The best design solution for all study models is the hybrid model, geometry number 3, in the combination with wood and steel materials. The model number 3 has a good fire resistance even for three sides exposure and showing the ability of wood to protect the steel when the wood is external to the profile, as you can see in this picture, representative of our best design solution. Thank you very much for your attention. Here you can see my address email. If you have any question, please contact me. Thank you so much.